this is basically how it looks inside. So you can see that it includes a lot of questions. And then I also put some answers in here. Now, keep in mind that I've highlighted the questions that are important. So the ones that are highlighted in this bold, those are the ones that I would recommend you to learn, and the ones that you are likely to hear during the interview. Now, everything else is more like additional information. Usually we don't get a lot of questions about the theory. Nobody is really usually asking us, like, what is an API and why do we need to do the testing? But just in case, I've also added that information to this document. So in case somebody's asking you one of those questions, you know how to answer those. All right, so let's start and let's go over this document. First question that we may hear during our interview is this one. How did you test an API? Or somebody may ask you, can you tell me about your approach? Can you give me an example of how did you test an API in the past? So if anybody's asking you this kind of question, I would highly recommend you to use an example and tell them a story, basically. Don't just mention the stages of testing. Don't just try to memorize them by heart. Instead, just come up with an example of API testing and provide this example. And then when you talk about the process, use that example and outline what particularly you are doing, which cases you verified, and then your answer will be much better. So people will actually understand that you have some hands-on experience doing this. The best example to give is to use login or sign up API. So our class number 4 and test cases from class number 4 are very good. So you can either pick user creation or you can pick a user login and just describe how exactly you are testing one of these APIs. All right, so let's get back here and let's say somebody's asking you this question: how did you test an API? Right. So in order to test the API, at first I would just get the documentation from the developers. In our case, basically developers would just provide the information on what is the base URL, what is the endpoint, which parameters it is expected for us to send in the API, and what are the responses that we expect to get, what are the status codes that we expect to get for different cases. And after I get this documentation, I will read through it and just make sure that it makes sense, it is full, and if I have any questions, I would clarify them with developers. So for example, when I needed to test user creation API, I would get through documentation. I saw that basically I was supposed to do a post to a certain endpoint. I would see the payload, and I also saw the responses that I was expected to get. So after I read through that documentation, I started to create test cases. So I outlined things to verify. And for example, for a user sign up, I verify that I can successfully create the user. I would verify that I cannot create a user in case I provide some invalid information like incorrect email and password. I would outline the fact that we need to send data properly in my test documentation. So we're definitely test for that. And after I create all these test cases, basically I start executing them in the correct environment, right? So when developers implement an API, when they build a new API, it's usually available in QA or a development environment. So I would make the API calls through Postman, basically pointing to the right URL with the correct environment. I would provide the correct payload at first, and I would just verify that things are working as expected. In case I needed to verify some negative behaviors, I would just modify my payload and make sure that API handles properly the situations when I provide incorrect data. For example, if I try to sign up and I use the password that is too short, or if I try to sign up and I send a blank password to the backend, and things like this. If I discover bugs during my testing, I would just report them to Jira, and if there is any bug fix verification needed, I would also do that at the end. So that's it. Just tell them a story. If they ask about more details, if they ask to clarify what you've tested exactly for a particular API, just mention more test cases that we've listed here. Usually, if you can name just off the top of your head, like 5, maybe 6 test cases for a user creation API or for a login API, that's good enough. In our case, I think we have about at least 15 test cases for each, right? So before an interview, definitely go through these test cases, memorize a few. And if somebody asks you during the interview, how would you test the login API or how would you test user creation, you can definitely come up with some test cases that we have here. So that's basically the approach. And again, when answering this question, it would be better if you could connect to a real API and tell the story based on how you tested something in the past. And that's it. Another question that I have here, what is an API? It's question number 1. This is not something that we will likely hear, and usually nobody expects you to give the definition. So if you can just explain in your words what exactly API is and how you understand it, that's good enough, right? Don't try to memorize everything by heart. It looks a little bit weird. So better just try to explain it how you understand it. And if somebody would ask me what is an API, I would tell them that API basically stands for Application Programming Interface. And basically, it's just an interface that allows two apps to communicate with each other. So for example, the main use case for us is using APIs in order to communicate with our backend side. So client side, our front end will be making calls in order to get some data, in order to post some data to the server, and in order to basically just talk to the backend. By doing this, we can display this data back to users, or we can perform certain features or certain functions inside our app, and that's basically it. So that's how I would explain it. Now, what is an API testing, right? So API testing is the type of software testing that basically is calling APIs directly and then verifies whether API acts as expected, right? So what we are doing, we are opening Postman, we perform an API call to the backend, and then we verify that we get back correct status code, the time is acceptable, the body is also correct. If header is supposed to be received through the response, we also verify that, right? So API testing is basically testing our API and verifying that it functions as expected. Now, keep in mind that in order to do API testing, we need to know what expected result is. So we always need to have some documentation that will outline exactly what's expected for us to get when we are working with this API, right? If we're trying to register a user, we have to have documentation that will tell us exactly what kind of status code we should get upon user registration, what kind of data will be sent to us upon successful user registration, and what kind of errors we are expected to see in case we are providing invalid payload, like trying to register with email that has been already registered. So just keep this in mind. What tools did you use for API testing? During this course, we used Postman, so that's pretty much it. Who can use APIs, web APIs? Actually, anyone. So anyone who can make an API call can actually use those APIs. So we can call APIs using pretty much any programming language. We can call APIs using our mobile apps or our web apps. We can make API calls using Postman. So any kind of app or program that basically can make a get, put, delete, or post request can use an API. What are the advantages of API testing? So API testing is actually very time effective comparing to our user interface testing. And if we are working with Postman, very often we can test APIs before the actual UI around the feature is implemented. We actually don't need to have a login page in order to test the login API. As long as we have the documentation like this, that outlines exactly what it is expected to get in case we try to log in. We can just generate this call using Postman, and that's it. We don't need anything else. And while we are testing this login API, our front-end developers can be just building the login page, so we don't even have to wait until they're ready. So it saves us a lot of time. Now, besides that, API testing helps to reduce the testing cost, pretty much because we discover a lot of bugs during the API testing, and when we file them right away. That actually helps. Again, we don't have to wait until the later stages of development when UI is ready in order to verify something. We can just discover those bugs right away. So usually the bugs are discovered faster. It helps reduce the testing cost. And basically, that's one of the main reasons. Another thing is that when you test APIs using tools like Postman, if you discover some bugs, it's very clear that those bugs are related to backend. So when you file the tickets, they go directly to backend developers, and nobody needs to actually look and try to debug your problem and understand if it's related to backend or to your front end, right? So for example, if you just use user interface, open login page, enter your login credentials, click login button, and you can't log in, right? The page doesn't work. Where does this problem happen? Is this happening because your API doesn't work, or does it happen because your user interface is not doing something correctly? Somebody from development team needs to go debug it and find out. If you are doing API testing through Postman, you just know right away. So the problem is related to APIs, so things go to the correct developers too. Now, API testing is language independent. This is not very important for us in manual testing, but more for your information. We can perform API calls from any programming language we want. It can be Python, Java, Kotlin, whatever. All these languages allow us to make API calls. And if we try to automate API testing with programming languages, we actually have a giant variety of languages and libraries to do this, which makes it very convenient. Now, API testing, as I mentioned a few times, allows us to test the functionality without the interface, and that is very convenient. And API testing overall helps us to reduce risks. There are some things that we can do with API testing that we cannot do when we use our interface. For example, trying to update the user without providing a token. We can do it using APIs, right? We just go to Postman, we go to our, what was an example here? We go to our headers, we just turn off the token that we were supposed to provide, and we verify that this API call doesn't return 200, we can't get access to user information. We cannot do this using mobile app or web app, for example, because they basically have the functionality already in, and they will be using tokens all the time, right? So it helps us to reduce risks, and we can cover way more with API. So that's another advantage. You don't have to memorize all of this. Obviously, you can name like a couple of items from this list. This is good enough. Now, question number 6. What exactly do we need to verify in API testing? So as I mentioned a few times, when we make an API call, we always analyze the data that we get back, and we verify that this whole API functions as expected. So the first thing that we test is data accuracy, right? When you try to log in as a user and make a login call, it should return you the correct information. It should return you the correct user email, username, whatever it is documented. It should return you the correct tokens, right? So we verify the data. When we made the calls to test weather, we verified that we would get back the correct information about the city, correct coordinates, correct temperature. So data accuracy. Now, status codes, right? If we make an API call and it is successful, it should return proper status code. So it should be some sort of 200. If we try to log in with correct credentials and login works, it should never give us back 400, right? It should always be 200 something. So status codes is another important thing. Response time. When we make an API call, we expect a quick response from the server. So if the response time takes longer than half a second or a second, it makes sense to usually bring it up to your developers. That's a bit too long for an API. Error codes in case API returns any errors. As I mentioned, API should never return in 500s, right? And if API is expected to return an error, you should get back the proper error code. So it should be 401, 404, 405, depending on the kind of error you're getting, but it should never give you 500s, for example. We also verify authorization, and that's what I just mentioned, right? If we are performing the operations that are only allowed for registered users, we should not be able to perform these calls if we don't provide the valid token and if we don't confirm that we are authorized, right? If we are trying to request weather information for basically using this Open Weather API, we have to provide the token. If we don't provide the token, we should get back a proper error saying that we are not authorized and we can't get this information. So we always also verify that if we are working with in-app experience or with all kinds of functionality that requires user to be authorized, we cannot do that without having authorization and without having token confirming that we have permissions to do this. This is not something we covered, but also APIs can be tested for all kinds of non-functional things, such as performance, security, and so on. This is not the responsibility of manual QA engineers. In fact, this is usually the responsibility of developers, but very often developers will also verify that if we, let's say, try to work with the same APIs, and let's say we simulate a load of a couple thousands of users trying to log in simultaneously at the same time, just performance testing, right? Our API will still work. Or if we try to break into our API, we actually can do that. Again, this is more from the development point of view, and this is not something we do manually, but this can also be done through API testing. Now, question number 7, name some tools used for API testing. The one that we used during this course is Postman, but keep in mind that there are a lot of tools on the market that allow you to do the same thing. One of the most famous ones is called PA. If you look it up, it's basically the same as Postman. It's literally the same, it just has a little bit different interface, and it is paid. I prefer Postman better, but that's another one. JMeter is another tool that you can also use for API testing. Now, if you don't name anything but Postman, that's good enough. Postman is #1 tool, and a lot of people these days actually don't even remember the older ones that have been in the market for some time. List some templates for API documentation. So during this course, we actually worked with Swagger. Maybe you didn't notice, but we did. Every time you open an API documentation and you see something like this, this format with highlighted methods, endpoints, clickable, when you see all the payload, this is a Swagger form of documentation. So I think another example that we used was http://bin.org. And in here, this is also Swagger documentation, right? So this is the format, like method, endpoint, and some information on what to expect. So this is what we were using. Now, besides that, there are some other tools like Flatdog, REST, API Blueprint, and so on. You can look them up if you're curious. Honestly, just from my experience, during my whole career, I've only worked with Swagger, and I've also seen API documentation kept on Confluence, which is like basically similar to Google Doc files that people were keeping for the company. I've never seen any of these tools, but this is just more for your information. If you can come up with Swagger, that's good enough. That's a totally acceptable answer. Now, question number 9. Name some of the API examples which are popular. So all the major companies that provide some external services usually have some public APIs. For example, Twitter has some APIs that you can take, and if you use them, you can actually implement like Twitter feed on your website. So that is famous. Google Maps APIs, very often used on all kinds of e-commerce websites. So for example, you shop somewhere in an online store, and then this store has the functionality to locate the stores next to you. Usually they use Google Maps API. Facebook, Amazon Ads, Slack, all of those companies have their own APIs. So they are pretty popular. Difference between API testing and unit testing. I don't think anyone will ever ask you this question, but also just for your information. During this course, we were doing API testing, right? So let's start with this. API testing is something that usually is done by either developers or by QA team, but it can be totally done by QA team through Postman. API testing is a form of our black box or gray box testing. I myself think that API testing is a gray box testing because in order to test an API, you need to know how to make an API call, which basically means that you have access to internal components of the system. You know how to make this call. Now, there are some developers and some opinions on the market that believe that API testing is a form of a black box testing because you basically not working with internal components, but you're just interacting with the app externally by making an API call. In any case, API testing is a gray box or a black box testing, right? It's one of these two. It just depends on the point of view whom you talk with, right? I usually say that it is a gray box testing. API testing is done after the API is ready. So we cannot do an API testing before API is built. And we don't work with any source code. We don't look inside the app in order to perform API testing. And that's basically it, right? That's basically what we do when we work with APIs. Now, unit testing is something that is done by developers. It's a white box testing, and unit testing requires to write code and build basically automated unit tests against the source code of developers. So source code is definitely needed in order to do unit testing, and that's another difference. Okay, now question number 11, main challenges for API testing. First of all, selecting the proper parameters, right, proper combinations. When we were trying to test our login API, we noticed that there are a lot of different permutations of data that we can make, right? We can try to log in with valid credentials, with invalid credentials, with email that is blank, with the password that is blank, with the password that's sent as integers instead of strings, and so on. So sometimes just picking and coming up with proper parameters can be a challenge. Besides that, another probably bright challenge would be to provide the proper sequence of calls, right? When we did the sequence of API calls in order to do the testing, we actually used multiple APIs. So we would create a path, then we would update it, then we would make a get call to verify that information was updated, right? And sometimes making a lot of these calls one after another can be challenging, especially if the sequence is too hard and requires 5 or maybe 6 calls done one after another. So that's another challenge that usually happens. Verifying and validating the data as well as categorizing the parameters, also another challenge, right? When we make a call, we have to make sure that we send the payload in the expected format, but also when we get the output, right? When we get back some data, for example, for user credentials or for weather data, in order to test that API, we would need to make sure that the information that we get back is totally correct, right? So validating this payload can be a challenge, especially if it's huge. In our case, this is a pretty short payload, but imagine the situation when you, for example, need to verify that you get back the correct playlist of songs, right? And your API response includes 200 lines with the information of songs of the playlist, title, links to the records, and so on. That can be challenging as well. And sometimes it may be difficult to provide the input values because we don't have user interface. And in order to get to a certain state or provide correct values, we have to be very careful with Postman, and we also have to make sure that we are sending back the proper information. Now, types of bugs that we face when we do API testing: improper messaging, incorrect errors, stress, performance, security issues, right? API can handle a certain load. API that is not supposed to work without token all of a sudden allows you to see user data without token. And basically, the error that we get through APIs tells us that we are sending some invalid information to the backend. The error that we see on the UI side is just we would use put. If we want to update our users, we can use put as well. So that's the major difference. Question number 17, the difference between put and patch. So put basically allows us to replace an object. Perhaps we'll always use the token. Name, we see on the UI side, is just the error to outline our users something they are doing incorrectly. For example, through UI side, users can enter incorrect credentials and they will see an error message saying you can't log in, right? But through the API side, we can actually try to break the API and request some information without the token, and we should get back an error message saying that you can have access. It's impossible to simulate this case from UI side because our apps will always use the token. Name some commonly used HTTP methods. Not going to spend time on this one. We've talked about it during this course. Get, post, put, delete, and patch are the common ones. Can you use get request instead of put to create a resource? No, we cannot, because get we use to get the data and put we use to update the data, so it cannot be replaced. The difference between put and post, right? So post is used in order to create some object, user, pet, whatever product in the store. Put is used in order to update a certain object or replace it sometimes, right? So if we want to update the record of our pet, we would use put. If we want to update our users, we can use put as well. So that's the major difference. Question number 17, the difference between put and patch. So put basically allows us to replace an object, and patch will update an object. From QA perspective, for us, it doesn't matter, right? When we do our testing, we look at QA documentation, right? So for example, we go to our documentation and we see which method is specified. For example, in order to update something, let's say our documentation says we have to use put. Okay, so when we test update, we will just use put. If the documentation says to use patch, we will just use patch. And that's it from our perspective. We just take the method from here, call it, that's it, things are working. Now, from the backend development perspective, the major difference here is in the implementation. So when backend developers implement put, what they're basically trying to do is the replacement of the object. So for example, if you make a put call and let's say try to update your pet, the backend will find a database record for this pet, it will delete it, and then it will create a whole new record with the same parameters as before, but it will update the parameter that you are changing. For example, if you're changing the name of your pet, that will be set to the new value, everything else will be the same. But technically it's a new database record, the old one gets removed. With patch, nothing gets deleted. So the backend will just go to the database, it will find the record, and it will just swap one value. So it will just update the name value in that record, but it will not delete it. That's it. From our perspective, it should just update the information. So we just do the code that it is documented for us to do and verify that things are working as expected. That's it. Question number 18, name some most common status codes, right? During today's course, during a current course, we've seen quite a lot of different API calls. You don't need to know them all, but you should be able to name at least 3, 4, maybe 5 right away because they are pretty common. So 200 means okay, and it's basically the successful response and means everything is working as expected. 201 means created, so very common response for user registration or just any object creation is 401. When we try to add a pet to the store, ideal response would be 201, it's created. When we try to register a new user, ideal response will be 201, created. This being said, developers very often don't do it and instead just say 200. Not ideal, right? Ideally, we should be doing 201. Now, 400, very common status code means bad request, basically saying the client side doing something incorrectly. We've seen it a lot when we were testing login and user sign up, and we would just provide invalid credentials, incorrect credentials, 400. 401, unauthorized, very common case when we try to perform some action, but we don't have permissions for it. So for example, when we were trying to get weather without the token, we would get back 401 saying we are unauthorized. Backend understands what we're trying to do, but we don't provide any token confirming our identity, so we don't have permissions, we don't have authorization to do this. This is 401. 403, forbidden. It's usually used when user doesn't have permissions to do something. So for example, if you registered just as a regular user, but then you try to make an API call that requires some admin permissions, you usually would get 403, forbidden. Not super common, but sometimes you see this backend call when you try to test some systems that like require some different levels of authorization. Sometimes 403 can be misused and like you're doing some actions and the website's trying to limit you from doing them because, for example, you're trying to log in with invalid credentials for too many times. Sometimes they return 403. Questionable 401, in my opinion, would reflect that situation a little bit better, but also another status code that means you don't have permissions to do something. 404, very common in case something's not found. So let's say you are trying to go to a page that doesn't exist. We very commonly see 404. And 500, internal server error. Server can't handle something, we see 500, right? Those are just few. If you remember some other ones like 405, that would be good. Again, just learn 3, 4 codes at least, so you are able to come up with examples right away. And a couple of other questions, 19 and 20. I just put them here more for your information. I haven't heard from anyone that these questions are actually being asked, but just in case, if somebody's asking you what is a REST API, REST is basically what we've been doing during this whole course. So during this course, we've been testing REST APIs, and this basically format is the REST, right? So it has the headers, it has the method, the URL. This is the REST. So REST stands for representational state transfer. It's basically just a set of kind of rules that helps developers to define the requests and define the responses that we should be getting back. So basically just a set of recommendations on how an API should be built and created. You can read a little bit more about it. Here is the link. But long story short, during our course, we've been basically testing REST APIs and the components that we've been working with, like method, URL, headers, body, and so on, those are the parts of our RESTful APIs. Now, REST is not the only way to make an API call. There are other ways to do it. SOAP stands for Simple Object Access Protocol. It's just another protocol that allows us to communicate with the backend. And that's another pretty common way of making API calls. Now, SOAP used to be very popular back in like 90s and zeros. These days, it's been pretty much fully replaced with REST. I've never actually seen SOAP for probably the last 6 years, like from my own experience, but you can still sometimes see APIs built using SOAP for some companies that have been on the market for a long time, and also some companies that really care about security a lot because SOAP is believed to be harder to break. So if you are curious about SOAP, there is a link on Wikipedia and you can just read some information about it. Keep in mind that SOAP APIs are pretty easy to test. They will also have very similar pattern. You will also basically have set of rules on how to make an API call. So if you know how to test the REST API, if you just understand that, okay, here I have some components of this API, this is how I send the data, and this is what I expect to get back, you can pretty much apply this knowledge for SOAP. You will just learn your own way of actually sending SOAP calls, but then the idea behind it is totally the same. We will just be using some different tool, not Postman, to make a SOAP call, and then we will just verify that we get back the correct information and the call was performed successfully. So if you are interviewing for a position that requires testing SOAP APIs, that's okay. Just tell them that you've never worked with SOAP before. You've been only testing REST APIs using Postman. That will be good for them. And it's very easy to learn how to test SOAP APIs if you have knowledge of just API testing in general, and using REST is a very good example. So this is pretty much it. Those are the most common interview questions for API testing. The most important one, and the one that we usually get during every interview that requires API testing, is this one. The first one, the story about how you've tested APIs in the past. So when preparing for interviews, definitely make sure to cover this one, and please go over the test cases. So in case somebody's asking you how would you test a certain API, you definitely can come up with example. A question about how would you test the login API is pretty common, and your answer here is just this document. You just need to come up with some test cases that are relevant to login, and that's it. So this is pretty much it. I hope you enjoyed this course, and good luck, everybody.